Welcome to this video tutorial on the topic of CEREC Primemill. In this video, we will take a look at the speed, the guided workflow, the usage of the data matrix code scanner, and the RFID tool reader in more detail. We will also present the new instrument concept. The new option of equipping the CEREC Primemill at any point in time, followed by pre-touching the block, will save your patients valuable time. The CEREC Primemill can be equipped with the instruments and the block both ahead of and during a patient appointment, no matter in which phase of the CEREC software you are. The pre-touching process is initiated immediately after the equipment, so that the CEREC Primemill is immediately ready for the manufacturing process. When using zirconium oxide blocks in combination with the superfast milling mode, crowns can be manufactured within 5 minutes, maximizing time savings for your patients, you, and your team. Next, we come to the guided workflow. CEREC Primemill is equipped with a powerful touch interface that guides you through all the workflows. Here, the start screen of the CEREC Primemill is displayed. In our case, the device is not equipped with a block or any instrument set, indicated by how the symbols are displayed and the plus sign at the center. At the bottom edge of the screen, 2 more buttons are located, with routine actions on the left and settings on the right. For more detailed information on these 2 buttons, see our video tutorials with the titles CEREC Primemill Routine Actions and CEREC Primemill Settings and Calibration. To equip the Primemill, we start by selecting a block. In our case, we use a CEREC Zirconia block, which is equipped with a data matrix code. The data matrix code contains information about the material, such as block size, color, batch number, and the magnification factor of the block, if applicable. For blocks without a data matrix code, the scan function on the touch interface can be skipped. Instead, manually select the manufacturer and block type from the database. After the scan is complete, the block information will be displayed on the touch interface. We will now show you a short video to illustrate this process. To begin, tap the plus sign to select the block. The data matrix code is located on one of the block surfaces, and we guide this side toward the scanner. Next, both the motors and the block axis move to an optimal position so that the block can be positioned. Make sure that the block is mounted in its final position in the block axis. The block is fastened with the torque wrench. As soon as a click is heard and felt, the correct torque has been reached. Next, you will be prompted to select the use case. In our case, with CEREC Zirconia, 3 options are available: mill and grind, extra fine milling, and super fast milling. The available use cases depend on the material. In our case, we select the last option. Then, we confirm the instrument change and continue with equipping the instrument set. Based on the block material and use case selected, the CEREC Primemill automatically displays which instruments need to be mounted, in which order, and on which motor. The instruments are equipped with an RFID chip located at the end of the instrument. For easy identification of the new instruments, they are color-coded, which we will look at in more detail later in this tutorial. Most of the instruments, such as the Burr 1.0 CS displayed here, are inserted and removed using the torque wrench with the triangular connection. The Burr 2.5 CS for zirconium oxide blocks, which is displayed here, requires a higher torque than all the other instruments. This can be achieved using the torque wrench with the square connection. The instrument mirrors the respective shape. The CEREC Primemill is equipped with an RFID tool reader. Therefore, the instruments are equipped with an identification chip, which the integrated reader of the device can read. The chip transmits information about the instrument type and its level of wear, which is displayed on the touch interface and stored in the device. Next, we will look at a video that demonstrates how the first instrument for the super-fast milling use case for CEREC zirconia is mounted. We guide the color-coded end of the first instrument onto the scanner, and if this is the correct choice, a green check mark is displayed on the interface. If the wrong instrument has been selected, an error message appears. We open the chamber and hand-screw the instrument onto the indicated motor. As mentioned earlier, each instrument must be tightened with the matching torque wrench. After mounting an instrument, we close the chamber, and information about the next step is automatically displayed. In this way, the motors are equipped step by step. At this point, we skip over the mounting of further instruments, the pre-touching process, and the manufacturing process of the restoration, and continue with removing the block after manufacturing. The completion of the manufacturing process is indicated by a green check mark on the touch interface, the bright green bar below the chamber, and the white light inside the chamber. To remove the block, we use the torque wrench again. Finally, we will turn our attention to the new instruments of the CEREC Primemill. To help with the choice of the appropriate instrument, they are color-coded based on the material to be processed and the processing mode. The instruments coated with white are diamond-coated grinders of varying diameters. They are used for wet grinding. The yellow-coated instrument is used both for wet and dry milling of zirconium oxide. The instrument with red coating is only used for processing PMMA blocks. The black-coated instruments are available with diameters of 1.0 and 0.5. They are used for wet or dry milling of different materials. The extra-fine instruments will also be available at a later time. Thank you very much for your attention. We would like to wish you every success when working with CEREC Primemill.